In a few of the previous lessons, we've started with equations, and we found ways to graph the lines that went with those equations. Here we're looking at a line, and what we're going to do now is try to figure out what was the equation that gave us this line. And we're going to try to express that equation in the above form, y equals mx plus b, also known as slope-intercept form. Well, the first thing we're going to do is see if there's some obvious points that have integer coordinates. This method doesn't work so well if we can't find some obvious points on our graph. But we've found two. And from those two, we're going to see if we can figure out the slope, which in this case is from one to the other is 2 up and 3 to the right for a slope of 2/3. And then we're going to take the m out and substitute the slope that we now know is correct for this graph where the m used to be. So now we're partway there. And the final thing, you may have already figured it out. We're going to figure out what the y-intercept is. That's not hard. We look at the purple line. We look to see where does it cross the y-axis. And of course, it crosses at 3. So we replace the b with a 3, and we're done. We now know that the equation that gave us the line shown here is y equals 2/3 x plus 3. We remove our scratch work, and now we're looking at both the line and the equation, only this time we started with the line and we used it to figure out what the equation was. Here's another example. We're going to see if we can mark out a few known points, and we found two. And one of them happens to be the origin, and the other one looks like it's +3 followed by -3. And we're going to use those two to determine that to get from one to the other, it's 3 down and 3 to the right. So that's -3 over 3, so the slope is -1, because -3 over 3 in lowest terms is -1. So we replace the m with a -1. And then, of course, we look for the place where it crosses the y-axis. Well, for this particular line, it crosses the y-axis at 0, and by coincidence, it also crosses the x-axis at 0 because it crosses at the origin. But the one we're concerned about is the y-intercept, the 0, so we take the b out and put in a 0. And then, of course, the most common way to write this equation is to simplify the right side from what we have here, -1x plus 0, to simply the opposite of x. So the most common way to write the equation for this line is the one on the right. Y is equal to the opposite of x. Now we're going to do something a little bit different. Instead of examining a line that's graphed, we're going to be given two ordered pairs. And our goal is to not only graph the line that contains those two ordered pairs, but find the equation that generated the line that contains these two ordered pairs. So the first thing we do is graph them, and there they are. And the next thing we do is to connect them and form a line. And now we're going to find the slope between those 2 points. I'm showing it by counting on a grid, but you could also use the slope formula to determine this slope. 10 up and 6 to the right, put in lowest terms, is 5/3. So our slope is 5/3, and we're going to replace the m with 5/3. And now we're going to examine the line that we just drew to see where it crosses the y-axis. And it crosses at 4. So now we know that the y-intercept is 4, and we substitute 4 in for b, and we have our equation y equals 5/3 x plus 4. Once again, we remove our scratch work, and what we're looking at now is the original two ordered pairs that we were given, the line that contains those ordered pairs, the slope of the line, and the y-intercept, and finally, up at the top, the equation that represents the line that we're looking at. Here's another example, two new ordered pairs. First, we graph our ordered pairs, then we connect them to form a line. Then we count out the slope, which is 5 down, 3 to the right, for -5 over 3, or -5/3. Then we substitute it in for the letter m. And now we need to find the y-intercept. But our line doesn't go through the y-axis, so we carefully extend it. We're allowed to do that because lines go on forever in both directions. When you're extending a line like this, be careful so that you get the exact y-intercept. If your work is sloppy, your line might be a little crooked and you won't have the correct y-intercept. But in this case, it's an integer, it's -1. So we replace the letter b with -1. And then we get rid of our scratch work again. And we also write the equation in the more common way. Instead of y equals -5/3 x plus -1, it's more commonly written y equals -5/3 x, take away 1. And in this example, both of the x coordinates are 6. So we graph our points, we connect them, and we recognize that it's a vertical line. And from a previous lesson, we know that vertical lines have no slope. And if we forgot, we can remind ourselves again, there is no y-intercept because it's parallel to the y-axis. And in fact, vertical lines can't be written in slope-intercept form. We just have to memorize that the equation for a vertical line is always x is equal to a number, and in this case, that number is 6. One way to find the equation of a line given the ordered pairs of 2 points that lie on the line is 1. Graph the 2 points. 2. Connect them to form a line. 3. Find the slope of the line using the 2 ordered pairs. 4. Extend the line if necessary so that it crosses the y-axis. 5. Find the y-intercept by examining the line. And 6. Write the equation in slope-intercept form using the slope and the y-intercept.